Hello and welcome to Cambridge Guru. Once again, we already finished up with chapter number 1, algebra. Next unit we are starting with is logarithms and exponentials. It has two topics. First is logarithm and second is exponential. So without wasting any time, let us start. What do you mean by logarithm? Logarithm is a way to look exponentials or indices in a different way. What do you mean by this is, for example, I have a number which is 32. Now there are two ways we can write this 32. One form is your exponential form. That means I can write this as 2 raised to power 5 as 32. Okay, this is called your exponential form, in which this number 2 is your base, this number 5 is your exponent or the index. That's why it is called an exponential form, and this 32 is our value, or you can say the output. Okay, another way of writing this 32 is this, that I can write this 32 as log of 32. Then I will introduce a number here which is written just as a subscript of log. This is 2 and this is equal to 5. Okay, this is called logarithmic form, where this 2 again is your base, this 2 again is your base, and we pronounce this, or we read this equation as log of 32 with base 2 is 5. Okay, this form is called logarithmic form. Logarithmic form. Okay, so what is the need of writing this 32? Because we already know that this 2 raised to power 5 equal to 32 means we already knew the index form of any number, 2 raised to power something or 3 raised to power something. So we already knew what our indexes, what our indices are, what our exponents. Okay, from our previous checkpoints and IGCSEs. Okay, but what is the use of, why the need is there to write this 32 in some other form? What is the need of introducing logarithm? So let us understand this. Suppose I write this 2 raised to power 2 is, we know this is 4, 2 raised to power 3 is 8, 2 raised to power 4 is 16, and let us say 2 raised to power 5 is 32. Okay, so what you are doing here is you are writing this as 2 raised to power x is equal to some value output y. So this is called exponential function. I'm not introducing the exponential function right now. This we will do later on. But here is important point is that you know the value of this x. What is this x? That you are changing the exponent from 2, 3, 4, 5 and so on, right? And then finding out the value of this output, which is y, right? Writing this function y is equal to 2 raised to power x. This is called exponential function. This we will do later on. Okay, so you are changing this x from 2, 3, 4, 5 and so on, and finding out the value of y. Okay, but what will happen if I say, for example, I ask you what is the value of 2 raised to power let us say x, and the value of output is 50. Okay, you know that output is 50, you need to find out this value of x. Right now, as you can realize here, that in this case I know the output, which is 50, but I do not know the value of input, right? So this might look familiar to you, that earlier in this case I know the input and I was finding out the value of output, but here I know the value of output, but I need to find out the value of input. So these are, you know, these two functions, I can say that these two equations, they look familiar to us because the process is inverse to each other. Okay, in the first case, I know the input and I was finding the value of output by changing the value of the exponent, but in this case I know the value of output and I need to find out the input. So these two processes, these two phenomena, these are inverse to each other, right? And how to find out the value of x, logarithm plays an important role here. Why? Because If I say that 2 raised to power 6 is 64, okay, but I have the value as 50, which is between 32 and 64. Meaning is that 2 raised to power 5 is 32, which is less than 50. 2 raised to power 6 is 64, which is greater than 50. That means this x has to be between 5 and 6. This is first thing. Because output is between 32 and 64, so this exponent should be between 5 and 6. Okay, but this, since the exponent is between 5 and 6, I cannot find an integer value of this x. Right? This x has to be in decimal or in fraction form. So what is the exact value of this input? How to find out the exact value of this input? Logarithm plays an important role in this scenario. Okay, and what this log does to this 2 raised to power x and how to write this equation in logarithm form, this we will see just now. Okay, so this is one thing, or you can say the origin or the need of introducing logarithm in mathematics. Okay, so what this logarithm says is that if a is greater than 0, means positive. What is a? Here in this case, a is your base. Okay, n should be greater than 0, means log of whatever number we are finding out, that number should be positive, it should not be negative, and this base should not be equal to 1. Then we can say that log of n with base a is x, if and only if a raised to power x is n. Meaning of these two statements is that if it is written that a raised to power x is equal to n, then there are some conditions on this base, on this n, that what are the conditions? That this base should be greater than 0, this should be positive. First thing is this. Why it should be positive? The reason is that if I write the base, let us say -3, and I am raising this power to x, right, and I am interested in finding out the value of n, right, because I have to do the reverse process. I have to do the reverse process. This n I know, and I need to find out this value of x. Okay, so why this negative base is not allowed? The reason is that since the base is negative, the output could be positive or negative. Why? Because if it is negative, I raise the power to some even number. If this exponent is even, then output will be my positive. This n will be positive. But if this x is odd, output will be negative. If it is even, output will be positive. So I do not know the value of this x, right? If it is positive, then x should be an even number. And if it is negative, and x should be an odd number. So there is an ambiguity here. If there is a doubt here, that exactly we cannot say that this x should be positive or should be an even number or odd number. Okay, so this base should be positive. First condition is this. And what this says, that this base should not be equal to 1. Okay, a should not be equal to 1. Why it should not be equal to 1? Because 1 raised to power something is always 1. 1 raised to power something is always 1. So this x can take any value, right? So there is not a unique value which you can put in place of x so that you can find out the value of this n. Or logarithm reverse process is not possible, because this x, as this x can take any value, because this will always give you the value as 1. Okay, x can take any value. So this base should not be equal to 1 and it should not be negative. Yes, of course, a between 1 and 0, this is allowed. Right? You can write 0.5 raised to power something is equal to something. Okay, why? This is allowed. This is allowed because answer is always positive. Okay, and this number should be positive. Log of only positive numbers is allowed, right? Because same case here is that if this n has to be negative, then this base has to be negative. First thing is this, and this exponent has to be an odd number. So there are various conditions involved if this n has to be negative, right? So because we are defining laws, we are defining a function which is applicable to each and every value of x or y, whatever, right? There should not be any, you can say, discontinuity, or there should not be any doubt, or some ambiguity in value of these x, that n should be negative, then a should be odd and even, right? There are various complexities introduced are there. So we say that logarithm of only positive numbers are allowed. So this n should be positive, right? So if this happens, means if you are writing a raised to power x as n, and if all these conditions are satisfied, then only we can find out the log of this positive value n. That log of n with base a is equal to x. As we call this a as the base, so we say or we pronounce this as the log of n with base a as x. Base here will remain same. Okay, and please notice here how we can interchange an exponential form to the logarithmic form and vice versa. Right, log of n with base a, this base a goes to the feet of x. Okay, this is how I remember that a goes to the feet of x, so n becomes a raised to power x, or you can say that x now is on the shoulder of a, right? If you have to convert or if you have to remove log and convert the equation into exponential equation, so this is how we can memorize that this x will be on the shoulder of or on the head of a, or x is in the feet of x, a is in the feet of x. Okay, so a raised to power x is equal to n. This is how we can interchange exponential form to log or vice versa. Okay, condition first is this. Please remember that if and only if, that if a raised to power x is equal to n, then only we can write log n with base a as x. Okay, and all these conditions needs to be satisfied if we have to move from log n with base equal to x to this. Okay,